Good day. I shall now present to you the actual implementation of my Plate 2, which is a temperature monitoring and control system. So the objectives for this plate is included in our plate paper, which is to be able to display and implement a temperature monitoring with control system using microcontroller, and the output will be displayed in an LCD. Okay, before I show to you the circuit construction, I shall first tell you the components and materials needed for this plate. So here is a picture of my functionality test, and I shall introduce to you the materials using this photo. So first is the highlight material, which is the LM35 temperature sensor. Here it is. It has 3 pins, and I connected it to a DuPont wire, a set of DuPont wires, such that I can freely maneuver the LM35 temperature sensor. So as you can see, that's the LM35 temperature sensor. So next is the microcontroller. This is the Arduino Uno, and next is the 2 DC motors. We use these DC motors as representation of the fan and the heater. This is the LCD display. It's a 16:2 LCD display. Beside it is the potentiometer. It is used to contrast the LCD display. And above the LCD display is a resistor, as you can see. So it is used to control the lighting of the LCD. What else? A set of wires for the connection. Other material, and another material that is included in the construction of this actual implementation is the L293D motor driver. It is not included in the simulation using Proteus because apparently in the simulation you can drive the motor using just the digital pin outputs as the driver of the motor. However, in the actual implementation, you need to use a lot more power in order to spin the motors, and the digital pin outputs does not have enough power to drive the motor. That's why you need to use a motor driver. In this setup, I just connected the motor driver into the 5 volts pin of the Arduino Uno, and the 5 volts power is the one that is being used to drive the motors. So that would be all for the materials, as I have explained, and now I shall show you the circuit construction of this actual implementation. So we're done with the circuit construction, and now I shall explain to you the connections of the circuitry which I have made. So here I actually forgot to introduce to you another material that was used in this project, and those are the LEDs. So here's the green one. There's a green LED and the blue and red ones at the bottom of the 2.1. Okay, so the connection of this is that the LED display, I actually connected it at pin A0 of the Arduino Uno, but I utilized that pin as a digital output. So I labeled the connection as pin 14 since it is A0. A1 is actually used as the input, the analog input for the temperature sensor LM35. Okay, so that's A1 for the temperature sensor. Other connections are the LCD display to the Arduino Uno. I just utilized the same connections as my previous plate, and I use digital pins 10, 11, 12, and 13 for the red and blue LEDs, as well as the motors. Okay, but the motors are indirectly connected to the Arduino Uno. Actually, the connection is that the Arduino digital pin is actually connected to the motor driver, and the motor driver is the one that is controlling the motors when the digital pins are set as high and low by the Arduino. Okay, so that's it for the connections, and before we proceed to the functionality test, I shall tell you about the errors that I have encountered in the construction of this project. So the previous errors that I have encountered in plate 1 also were also present in this project. Those were the loose connections, loose wirings, and the 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 contrast of the LCD display. So the LCD display does not function directly because the contrast is not right. But the additional errors in this construction of the project, as I have mentioned earlier, is that the digital pin is unable to drive actually the motors for this project. That's why we needed to include this L293D motor driver for it to happen. Other errors I have encountered is that at first I have pinned the LM35 temperature sensor at my circuit board, and as I have pinned it, I realized that it is difficult to actually test to actually perform the functionality test because it is pinned at the circuit board. And for us to be able to perform the functionality test, we need to heat up the temperature sensor using a lighter, and cool it down using an ice cube. So for that to happen, we need to move actually the whole breadboard to do it if the LM35 is connected to the breadboard. Hence, I use the DuPont wires such that I can move in a longer distance the LM35 temperature sensor. So those are the errors that I have encountered, and now let us proceed to the functionality test of this project. So this is my functionality test. This is the LM35 temperature sensor, and I will be using a lighter to increase the temperature and an ice cube to decrease the temperature. So as you can see, the sensor reading is at 30 degrees Celsius and its status is normal. Now let's try to heat it up.
So now, when it heats up, the motor representing the cooler or the fan is turning, and the temperature is greater than 35 degrees Celsius. So the status indicates that the fan is on. And this setup will continue until the temperature is greater than 35 degrees Celsius. Now let's try to decrease the temperature using this ice cube. So let me put the sensor here. As you can see, the temperature is slowly decreasing. When it is less than 20 degrees Celsius, it will turn the heater motor on, which is this one. So as you can see, the temperature is now below 10 degrees Celsius and the heater is on. The motor is also on. So that's all for my functionality test. Thank you.